Well, hello friends, welcome back to browser hacking. Today we are going to modernize our browser a little bit because until now we've been running the browser in a single process model. So what that means is that we have this browser here, and say that we have two tabs open. We'll open Google in a second tab. Both this page and this page here, they're actually both running in the browser process. And that is not very good for security, stability, performance, really anything, because if anything goes wrong, then all of those pages can step on each other's toes, and we don't want that. And there's all kinds of reasons that we want to do this. The only reason not to do it is because it's tricky, but who cares? So what we're going to do today is start moving towards separating out the web page rendering and scripting and all of that stuff into a segregated process. And then we'll have one of those processes for every tab that you open. And then hopefully, as this matures, we'll be able to scale back the amount of access that these processes have to the whole system. So we'll run them as an unprivileged user, and we'll tighten the sandbox around them and remove all kinds of access and privileges and stuff. But we have to start somewhere, so today we're just going to try to get this process up and going, and maybe have it render the welcome page here, and see what kind of architecture we can come up with. So I guess we'll start by just adding this process. So we'll go in services, and we'll call it, well, we already have web server, so we could call it like web process, web content host, web content. Although it sounds a bit like we have web content in this directory, like HTML pages and stuff. Web content host. Yeah, web content host. That's pretty cool. So here, let's just grab some files from somewhere. We'll take the ones from protocol server. And then we'll immediately turn around and delete a bunch of stuff that I don't care about. Maybe I should have just copied the stuff I needed. Okay, so we'll need a web content host server IPC and client IPC. So we'll need an IPC protocol, obviously, for the content host server and content host client to talk to each other. And we'll go here and edit this a little bit. So web content host. Let's get rid of host from the name. It's too much to say. We'll just call it web content. So we'll be starting with something pretty bare bones. Web content will be the name of the program. Yes. Web content, and in there, well, the libraries that we need are going to not be that many libraries, actually. We'll need libcore, libipc, and libgraphics, and obviously libweb. But I think it would be nice if this becomes its own thing, so it's not like baked into libweb, but it's a separate thing that just runs sort of an instance of libweb in a separate process, right? And then we'll make a widget somewhere that is a view into a web content process. Something like that. We can call it like a web content view, maybe, or web view, web content view. I don't know what we'll call it, but we'll start with this. So now we're here, and let me rename those things again. Client IPC. Okay, gotta get the names right. And then we'll add it here as well as in official subdirectory. Web content, all right. And let's come up with some IPC for this stuff. So we'll need, I guess we'll call this web, not web server, web content server. And we'll use the the endpoint ID. What's a cool number? 89. Very cool. I don't know why. And then we'll get rid of these guys. And this guy, we have to have a greeting, but the rest we can come up with ourselves. And for the web content client, his number will be 90. Very cool. Okay, so what kind of stuff are we going to have here? And what's on either end of this protocol? I'm thinking that in the client direction, so these are messages, this will be like, the web content client is the GUI side, so like the browser app in our case. And there, messages we want to send from the web content process to the browser are stuff like mouse down, right? Like if the, or wait, no, hold on. This is the wrong direction. Web content server is that process, so we want to send him mouse down. And I guess we'll say like, this is where we clicked. Position, and maybe which button, right? And this can be an asynchronous message for simplicity right now. Mouse up. We will include all of the button masks stuff. Nice to have. And actually we'll probably need all the modifiers as well. So let's just remember, that's like the Alt, Control, Shift, stuff like that. And let's not add too many more things here. But when we're sending something from the browser to the, wait. This is from the browser to the web content process, right? And then here, this is from, I'm going to write this out because I keep getting confused. From web content process to browser. From browser to web content process. Okay. So what does the web content want to inform the browser about? Maybe like, did finish loading a URL, something like that. And we might want to tell him something like load URL. Okay, and then let's not get too carried away here. So I think we have a pretty decent start. Then the only thing we want to do that's really important is we want to paint. So for a basic initial architecture, I'm thinking that the browser program will allocate a bitmap and just give the web content process the shared buffer ID of the bitmap, and then the web content process can draw into that bitmap and then just inform the browser process when it's finished drawing, and then the browser can show it on screen. So I think some simple architecture like that we can start with, and then later on we'll have to do something more sophisticated, like maybe dividing the content into tiles and stuff like that. But right now let's just do a big bitmap buffer and sort of coordinate drawing. So we'll tell him paint. 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 How should that look like? Graphics, maybe the rect that we want painted and the bitmap ID that we want it painted into. So shabuf ID. And yeah, something like that. And then he can say like did finish paint. Maybe this should be did finish load as well. Finish load. Yeah, that's fine. Maybe did paint even. And all right. And then of course, what happens here is that we ask it to paint, but then until he responds to us, we can actually do other stuff. So like if the web content process does not respond when we ask it to paint, that doesn't mean that we want to block the browser, right? Like that's one of the big reasons that you want to separate into multiple processes, is that if one process stops working, then you can still carry on with your GUI. So we'll have these be asynchronous, paint and did paint. Okay, I think we'll start with this. So I guess that means that we'll do one, how do we want this to work? I'm thinking we'll do like one process per tab, but it does create a little bit of a problem when you open like, you have a tab, then it opens another tab using like window.open or something like that, because then they're supposed to be able to reach each other via JavaScript. But I feel like if we, since we don't support this already, I wouldn't be breaking anything. And then if we just create the situation like this from the beginning, that every new open page is a new process, that means that we have to deal with that later, like figure out a way to communicate across process boundaries, even though we're in JavaScript. We'll deal with that later, is my point. Right now, we just want to do this. Okay, so this is a good start. And wait, is this thing mounted here? It was, all right. Wait, I want it to be here. Web content, and then we want to edit the web content main. So we can definitely strip down his privileges quite a bit already, I think. Web content. So we'll be starting with that inet, no internet access. Maybe we can skip these things too. Like you don't really need to read anything. I think he will need to talk to the protocol server, so we'll give him a connection to there. Oh wait, that stuff was set up that way for a reason. Let's see, protocol. That's fine. That's the only thing we need to talk to, I think. But of course, somebody is gonna connect to us. So longer term here, the idea is that we will have a single system server service that listens on a socket, and then you can connect as many times you want to that socket, and every time you connect to it, it will just give you a new web content process. And that feature has already been implemented by Sergey, but I haven't messed around with it yet. So I think we're not going to spend so much time on the service spawning stuff today, but rather like get the basic feature working instead. So I think we'll be using the legacy system here, the legacy, but like the single service process system for now. So we'll just take over a socket, and then we can work out later how to make it spawn a new one every time. There's some way to do that, but I haven't looked into it too closely that I remember how to do it. So we'll say web content. Or no, wait, we want this to be same as protocol server. Web content. Temp portal web content. Socket permissions 660. I believe it should be lazy, and it will be kind of interesting to run it as a separate user immediately. So let's just try that, see what we can do. And it should be in all boot modes. No, it should only be in the graphical boot mode because web content is not useful in text mode. I would think. So let's start with that, and we'll add the user account for him as well. So you'll be web content, UID 15. And we'll put him here as well, web content, UID 15, and Anon is a member of the group. All right. So here's the start. So when somebody connects to us, we'll start a web content client connection. So that's a connection from the browser to us. And this here has to change quite a bit. So web content. Oh, wait, hold on. What am I doing wrong? Protocol client endpoint. Oh, did I forget to change something? Yes, right here. Okay. Oh, shit. The IPC compiler does not tolerate comments, maybe. I didn't know. I thought it supported comments. I think we'll just remove the comments for now, because now I can remember which is which. And this guy is, no, what do you call then? Web content server endpoint? Do I have to say services, web content server endpoint? Like that? All right. That's fine. Okay. So, how do we implement this magical thing? So get rid of the old APIs. Web content server. Okay, so we should have these are messages that we need to be able to handle, so we'll just put them right here. Okay. And then we'll have to implement them in web content client connection. So first, let's just get rid of the stuff we copy pasted. Blah, blah, blah. And let's copy paste some other stuff that we actually need. And we're almost there. Okay. And okay. Cool. So here is that particular thing implemented. Great. And then, oops. So we're probably not going to implement all of these things right very now, like the mouse down, mouse up stuff, but we'll just put them here anyway, just for to give ourselves like a little context and to feel like we're in the right place. Oops. All right, so that's pretty good, and we'll start with load URL maybe. What I'm thinking about is, should we allow multiple page contexts in a single web content process? In terms of security, it's probably best not to do that, but instead have a separate process for every page context, and then if they want to talk to each other, it's just going to have to be awkward IPC proxying of everything. So let's just do that, and it'll be painful down the road, but that's the problem for our future selves. So it'll be worth it. So load URL. So a client connection. So the thing is, now we need to, every client connection here is a connection from the browser program. Or more specifically, it's really going to be a connection from a like a web content view widget, but the first and primary user of this widget is going to be the browser, obviously. So we can think of it that way, as the browser side. So he connects to us, and then he says, or he thinks of us as like a remote libweb instance. So we need some kind of libweb object here. And currently in libweb, we have this thing called a page view, which this is like the single process widget, and it has this guy right here. And the page is the engine object that represents a web page. So a web page has a frame tree, and then each frame in the frame tree has a DOM tree and a layout tree and render stacks and all kinds of stuff. So this will be our object to like hold the whole web page. Everything hangs off of this object right here. Web page. Web forward. And when we instantiate a client connection, we will also instantiate the page. Web page. How do we create these? We just create one like that. Okay, so we need to provide a page client, which means that our client connection, either we need to set up a page client object, or we need to let's see, we can make it a page client, but it's already so many other things. Maybe we should have a separate page client object. Let's see. Web content. I guess we can call it page client H. Yeah, we'll put this in its own little world. It will be web content page client inheriting from web page client. Okay, and then we'll make we'll instantiate one of those guys. So we'll put this guy here. Page client. Something like that. Page client, and this will be a page client create. Maybe the setup is stupid. We could also just call it like page host. Yes, let's call it the page host. Then I get that host word in that I wanted originally. Okay, because then we only have to hold on to one thing in the client connection. So create. Okay, so this will just have a page host here. We don't need anything from the web, but we do need something here. So here we'll put a page host. Okay. So what is this mythical page host? Well, let's figure that out. So namespace web content, and we'll include libweb page.h. Class page host is a public web page client. And not only is it a page client, but it's also the owner of a page. Boom. So the purpose of the page client interface is to, it has all of these different virtual things that the libweb page object can notify its page client. So I reorganized everything in libweb so that whenever the engine, the inner part of the engine wants to talk to the outside world in some way, just say that like, hey, the user is selecting some text or clicking on a link or whatever, in some way that the sort of the more GUI level layer needs to respond to, then it communicates outward via this page client interface. It's not completely implemented that way, but it's like almost all the way there, and that's the purpose of that was to enable what I'm doing now someday, which we're now starting. What do we do here? I guess I already implied that there's such a thing as create, so we'll do this, page host, create, and this will just be return, adopt, own, new page host, Bloof. Not the most interesting API, but there it is, page host. And that's a decent start, I think. So let's go and look in the CPP file for this, page host, CPP, no. Okay, there we go. Page host. So actually this we can write it this way, it doesn't really matter. So what is in this page host object? Page host. We need to construct the page. So mpage is adopt own, or maybe even, oh, we can use adopt own. New page, and we just have to give it the client, so that's us. Let's say web page. Oh, client, that's this, sorry. There we go. And we should probably make this non-copyable, and likewise non-movable. And then we'll give it a public destructor. We'll put that out of line just for simplicity. And we're off to a decent start. Maybe we should use make here. Doesn't really matter that much, but so it's always nice to see one less naked new, or one less new in general. Like, this is not my favorite thing. The reason that I use a drop down here, by the way, instead of make, is because if I use make here, it will fail, because this constructor is private. Okay, it does not tell me that it's failing. Why do you not see that it's failing? Somebody needs to tell me that it's failing, otherwise my life is a lie. So web content cmake page client was renamed to page host. There's so much stuff going on here. Okay, well, at least GCC complains about this, so we can't use page host, the page host constructor like that because it's private. Surprised that Clang doesn't complain. Anyway, we can just use drop down. Okay, and then in the web content server endpoint, it's upset about a bunch of things, calling no member named point in namespace graphics. What? Yes, there is. What are you doing, bruh? Okay, this code is confused about something here. I'm really confused. I feel like there's some this is some cascading failure. Page host, is that not what we called it? Page client. Page host. Why the big failure? I don't get it. What's the first failure? Rect in namespace graphics does not name a type. Oh shit, that's actually true. Oh, it's because of me. I forgot. Web content server IPC. These things are not called point anymore. They're called int point, because we also have float point and float rect. So that's entirely my bad, trying to use a type that's no longer there. Services, web content. Let's try that again. I still put graphics rect somewhere. Probably in the other direction, yeah. All right, we have almost a build. So let's go in the web content client connection. So here, we got this load URL message, right? And that message has a URL. This is the thing that we want to load. So what we want to do here is we want to say to the page host, we'll tell your page, and this is the part where we need to actually expose some stuff. Web, lib web page. And then here, oh, we already had that include actually. But here we should expose the page. So page. Something like this. So this means that we can do a load with the message.url. Boom. And this will be the basic way that we handle incoming messages to this thing, right? Like we have our page host, and the page host is where the whole web engine object graph hangs off of. And then when we get messages on the client connection, we'll proxy them to the page host object or to the page host page object. In fact, we could be lazy and just make a convenience getter like this and put that here, like page. We'll put that out of line actually, web page. Something like that. And we'll just put these guys up top. Oops. Kunst. All right. There we go. So now we can just say this. Very nice. And then we should be able to say other stuff too here, like page handle mouse down. And then we can just give him the information from the message. So message dot position, message button, message modifiers. And same thing for mouse move. Mouse move takes buttons instead. And that's probably mouse up is the same as mouse down, I would assume. Okay, so that's pretty straightforward. And then page, so paint, we don't have anything for painting a page quite so nicely yet. But these guys are pretty straightforward. So when we get a paint message, so this thing contains the, actually let's look at the IPC endpoint definition here. So we have a rect. This is the rect that we want to paint. So this will be, let's call it the content rect. So this is like the web content rect. So 0, 0,0 is the top left of the web page, right? And you can just tell it like, hey, paint me this part of the web page, and paint into this buffer. And I think we can say that the contract here is that the buffer is always the same size as the rect. This is a bitmap with the same size as the rect. That'll be okay. Okay, at least to start with. So now we need to actually map the shared buffer. So shared buffer is shared buffer, create from shabuf ID, message, shabuf ID. Okay, so if that fails, if we can't map that shared buffer, then we'll say did misbehave, cannot map shared buffer. Very sad. Press F in chat, and actually we'll just return here. But because we called did misbehave, this will disconnect the client, and it will cause everything to fall apart, because we have a very zero tolerance policy when it comes to the integrity of IPC in the system. Like if somebody misbehaves, we don't try to recover. We just die, or we let the connection die, I should say. Okay, but if that does work out, then we want to paint into it. So essentially we want to do something very similar to what the page view widget that we have today, what he does. So maybe we'll put this into, should we put this in a separate function maybe? Or I don't know. Actually, let's just do it here for now. So we'll go and fetch the code from page view. and see what he does for painting. So this is the paint event code. And let's just grab all of this and we'll paste it here. This will be kind of hackish, but actually maybe we should move this into the page host class. So we'll call page host paint message content rect and shared buffer, let's say. Okay, and then let's add something to the page host class for this. So we'll just have like a paint function. So graphics interact content rect and a graphics bitmap. That's where you'll paint into. It's a very, very simple API, but I kind of like it. Okay. And of course we'll need libgraphics painter. Oops, we can't use libgui here because libgui requires a connection to the Windows server, but we're not going to let the web content process have a connection to the Windows server because we want to take that out of the equation, right? So we'll have something more like this, target or similar. And then instead of making a GUI painter, we'll just make his base class graphics painter. We're painting into target. And maybe we can assert that. Actually, that thing is not a bitmap yet. It's still just a shared buffer. So let's go in the client connection class. So we need to turn this guy into a bitmap. So shared bitmap is graphics bitmap create with shared buffer graphics bitmap format RGB 32. We don't need alpha for this because we're gonna ask that the web content fill everything. I think we don't care about, no, we don't want to have transparent web content. That'll just make a mess of everything, make everything much more complicated than it needs to be. And the shared buffer, I guess we can just move it, actually. And we need the size, so that'll be the message content rect size. All right, and then we'll be passing the shared bitmap like that. Actually, I suppose this can fail as well. So if shared bitmap fails to allocate, I'm going to say cannot create graphics bitmap wrapper around shared buffer. And let's also say which message is failing here, just so we have some idea. Okay. But if that works out, then we don't need to clip anything. So the layout route is going to be, that is, we get that from the page, main frame. We need to get a frame up in here, so libweb, frame, and libweb layout document. So document layout node. Okay. So if we don't have a layout route, our layout tree has no root, then we can't paint anything. So then we'll just fill the whole thing with white. Otherwise, let's see. So then we want to fill, let's create some helper pointers here to make this a little easier for ourselves. So if we don't have a document, then we also cannot do anything, so we'll just fill with white. It's a little awkward to do it that way. I feel like we should actually always have a document here, so we're just going to make that into an assertion. But the document might not yet be laid out. But our main frame should always have a document in it, otherwise something has gone very wrong, and then it's better to assert, I think. Of course, now I've cursed it, and we're absolutely sure to hit this assertion today, but we'll deal with that then. Okay, so then we want to fill the content rect with the background color of the document. And the palette. So we don't have access to the system palette here, and we don't have a good abstraction for it. So we're gonna have to, we'll just make a fake palette maybe. What happens if we just make a fake palette? Can we do that? Palette. No matching constructor. Right. Maybe we can send him a palette. Dang it. Why did I build it this way? I mean, this is, it's not a bad design, it's just, the palette comes from Windows Server, and Windows Server broadcasts the palette to everybody. But since we don't have a connection to Windows Server, we don't have a palette. So maybe right now we can just hack it. So we'll allow you to create a dummy palette maybe. Create a dummy, let's say. And what is a dummy palette impl? I forget how all of this works. You just need a system theme object. Oh, yeah, right. So, okay, so very hackish right now. So void page host palette, graphics, or set up palette, I don't know, something. I just want to segregate this from everything else. And we'll call that in the constructor. Fix me get the proper palette from our peer somehow. Okay, but in the meantime, since we don't have a proper palette, we'll just create a dummy one. So we'll use the graphics system theme. Graphics system theme. Palette. Palette impl create. I guess now we have a shared buffer, so we can just pass this. Then we didn't need that dummy function. And then we just, I mean, we can just leave it like that. Maybe we'll put something nice in there. So like, theme is system custom theme data. Why can't I do that? There's no data, right? Because it's a shared buffer. Okay, and then we'll set color graphics. Oh, what are these? Color roll, background. I just want to set some colors so that it's not completely stupid. And then what are these objects? They're color objects. Okay, so this guy will just be color blue. Please work with me. Okay, so background, and then we have text, which will be color red. I thought it was called text, but it's actually the ones I'm looking for are window and window text. Okay, so if we get these colors, then we know what's up. Maybe magenta is even better, because it's officially the best debugging color ever. All right, magenta and cyan, CGA represent. So, we'll call it mpalette impl maybe, or just mpalette is, how do we store this? Palette, you can't default construct a palette, can you? No, you have to have an impl. All right. Then we'll store the impl and palette. Wow, there's so much work to set up a palette. And it's not even a real one, it's like a dummy one that we're gonna have to fix anyway later to be correct. So much work for a hack workaround. But it'll be okay. So we'll store this here. This will be a ref putter to graphics palette impl and palette impl. And like that. And we'll just return graphics palette with mpalette impl. And everything should magically, just super magically work. Hopefully, maybe, possibly. Probably not. We'll see. Okay, so that's good. Now we can check for the background bitmap, which we fetch from the document. And if we find one, then we just fill the entire content rect with the background bitmap. Obviously, there's a lot of work that can be done in the web engine to reduce the amount of overdraw that we do. Like currently, we just draw back to front, and we'll draw the same stuff over and over and over sometimes, which is not super great, but it is what it is. Scrolling, I did not think about scrolling at all, so I think maybe we'll just ignore scrolling at the moment. Okay, and then we'll need to instantiate a web rendering context, and it will have no translation from scroll bars because we're ignoring scrolling. So that's a graphics int point scroll offset, I thought. Am I wrong about this? Oh shit, it expects a GUI painter. Well, that would probably just work if you switch it to a graphics painter. I think it shouldn't matter if it's a graphics painter or a GUI painter. The graphics forward. Because one of the nice things about the libGUI painter, if you look at it, the implementation, it's actually just a subclass of graphics painter. So GUI painter, it's a graphics painter that adds this convenient API here that takes a widget. And what it does is that it just creates a painter, a graphics painter that knows exactly how to paint into the backing store for the window with that widget inside it, if that makes sense. So it's really just a convenience constructor, GUI painter. Nothing more to it. So we can just switch the web rendering context class to take a graphics painter instead, and that'll be it. Okay, and then we have some debug settings that I think we don't care about. So bloop. And viewport rect, we're just going to say that how big is the viewport rect? I guess that's the content rect at the moment. And then we'll call layout root render. Okay, so what do we do when we say page host paint? Create a painter, get the document, assert that we have a document, and then we'll just get the layout root for that document. And if we can't find the layout root, we'll just fill the whole thing with white. Otherwise, we'll fill it with background color, and then we will possibly fill it with background bitmap. I feel like we could do either one of those, or no, we can't. Not without being smarter, I remember, because sometimes people have like a semi-transparent background bitmap, so they'll have a background color, and then they'll have a transparent or partially transparent background image, and then you expect to see the background color underneath the transparent image. So yeah, we have to actually draw the background color first. Although if we were clever enough to sort of detect that the background is completely opaque, then we could skip over the pass where we draw the background color. But right now we don't have the ability to fetch that information, so it would be a nice optimization for the future. I guess you would have to essentially scan the entire bitmap to see if there is any alpha. Or of course, like if you know from the decoder that you loaded something that has no alpha, then you can just say like, oh, this thing doesn't have alpha. But that would be useful information actually for this type of stuff. And I guess elsewhere too, because then you could blit without alpha blending. Anyway, so let's see if we can build this pupper. And I think we're not going to start integrating this in the browser right away, but we will instead build like a little test harness for this thing, or like a little test program that we can use while we bring this up. So using a deleted function, well. Where did I say create with shared buffer? That must have been here somewhere. And that shared buffer is a ref putter, and you're expecting a non-null, so I'll release a non-null for you. And then finding this reference. Oh wait, hold on, yeah, that doesn't need to be a mutable reference. What was I even thinking? See, this was a stupid, yeah, I should have seen this right away. Like, this is a nonsensical declaration, because like, why would you want to mutate the content track? That makes no sense. Okay, so I think basically we have our little program. So let's see if it like can actually run. We're not going to be able to see what it's doing, but we can at least see if it starts up. Although we can't even connect to it yet, so let's not get carried away. Let's instead build a test program that connects to this guy. So what do we call this? This will be like, let's go in demos, I guess. We'll call it the web content view for now. Or maybe web view. Web content view. Yeah, web view is pretty okay with me. And what do we put here? Let's grab some gunk from some other thing. So CMake lists, just a main file, that's fine. Web view. So we want libgui, libgraphics. Well, that's implied. We want lib. I guess we really just need libgui, and it will pull in everything else for us. But we do need some other stuff. So like, we do need the where's all this gunk? We need the IPC header stuff. So normally we would create a library to do this, but what if we just include them like this? We don't have to create a library for this just yet. web content. Okay, so we'll have main, and then we'll also have, actually maybe this is okay, just for starters. Okay, so touch main. Add subdirectory. Okay, so what is going to happen in this holy file? I guess we'll start with int main. And we will need lib GUI window widget. I don't know. And we can start our own little. I guess we should add some kind of view widget here. Web content view. Let's call it web content view. Yeah, that's a cool name. And we'll build this class here in a demos directory for now, and then, you know, when it matures, we can move it into some library or something. I don't know, but we'll start like this. Okay, so web content view, and what is a web content view, I wonder? Surely it is a GUI widget. Oopsie doopsie. Triple oopsie. Okay. So it's libGUI widget, maybe even a libGUI frame, because why not? Gotta look good. It's a phonal public GUI frame. All right. And before we think too much about that, let's just go and instantiate some stuff here. So GUI application app. No, not about dialog. All right. Window construct. Boom. And window set main widget. How about one of those web content views? What do you say about that? Web content view. All right, and window set rect. I don't know, 100, 640 by 480. Cool resolution for sure. Set title. Web content view. I don't know, it's not super important. The important thing is that we show it. And then we run the event loop. Okay. So web content view, this guy, he wants to connect to the other side, right? We want to connect to the web content process. And we need some kind of connection object for that. So we could use, let's see, let's grab something for this. We'll take the way lib protocol has a client object, so I think we'll borrow that. And we'll just call it like a web content client CPP maybe. Okay. And I'm thinking we're just going to instantiate that here like this. Or wait, it's going to be a core object, so it'll be a ref pointer. Web content client. Okay. Like that. And web content client, like double that. All right. So web content view. And of course the famous destructor. Alright, that's enough typing here in this file, so we'll go to the CPP file and sketch this out. So this will be a web content view. Did we forget Pragma once? Yes, we did. Okay. Okay, and return and client. Okay. Oh shit, I put that in the wrong place. There we go. And let's put them in that order just because it's slightly nicer. And we don't have a namespace, so skipping over the namespace part. And here we'll say mClient is web content client construct. Right. So this is how we'll do that. And then we'll include that content client.h. Wait, is that not what we called it? We just called it client. We'll rename that quickly. All right. Oof. Okay. And then this thing is not a protocol server, so we need to bring in the web content IPC stuff. Okay. And oops, web content. Here we go. Oops. We'll just call this the web content client, right? And he will have some other messages. So they will be virtual void, handle, did paint, and, oops, what would we call it? Did finish load, right. I think those were our messages that we had. Okay, so web content client, we can get rid of, oh, this is copy pasted code, so web content is web content client, get rid of you, client, right, web content. Web content. So this is where we provide the address that we connect to locally. And then there's a bunch of gunk that we don't need. Okay, and now we just have to implement those two functions that we had. So that would be the did finish load and did paint. Web content client did handle did paint. I think what we'll do here is we'll just say like handle web content client did paint. Maybe we'll do the we'll dump out the rect and the share buffer ID that we got. Oh, I called it rect. I didn't want to call it that. I wanted to call it the content rect. Oh, and not with a space in it either. There we go. Content rect and shbuff ID is message shbuff ID. Not right now, sweetheart. My cat. Still a bit unhappy about the whole situation with not going outside. But that is life. So we're actually not sending this message anywhere. Let's take care of that right away. So web content page host. After we paint, here we can really just say like did paint. So we can do that right here, which is where we call paint, and then we'll just say post message messages. Web content client did paint. And then we just give back the original content rect and shared buffer ID that we got from him. Okay, there we go. Oh, what did I mess up now? Forgot something. Okay, oh, we forgot to do the did finish load. So web content client handle did finish load. So here we'll just say handle web content client did finish load. URL is message URL. All right. So everything builds, that's pretty cool. Now let's see about adding a load API to this thing. So we'll have like void load const URL, something like that, very basic. And what that will do is we'll just forward this request to the web content process. So we'll say client post message, I guess. So we'll say post message messages web content server load URL. Okay, there we go. And maybe we should print that we received the message actually. So handle web content server load URL. Okay, and then we can do the same with paint actually, because it'll be pretty interesting to see what we get here. So here we got the content rect and the shabuf ID, which is like that. Content rect. So we want to take care of this in the paint event of the web content view. It'll be a GUI paint event. Okay. So when we get told to paint ourselves, what we're going to do here is create a GUI painter to paint into this widget. Which, as we now know, we saw before, this is just a convenient wrapper that paints into the backing store of the window that contains this widget. Okay, and then we'll clip it to the paint event so that we don't draw too much. Or at least we don't draw stuff that we can avoid drawing with the knowledge that we have. And then we should really be doing the frame first. So frame paint, followed by our own paint. And I always forget how to do this, so let me look it up right quick. What we do is we just clip to the widget inner rect. Okay. Is that not how you do that? Frame inner rect, maybe? Yeah, okay. You know, maybe worrying about frame is premature here, so let's chill out on that and let's go back to being just a regular widget. Because this is tricky enough, like we don't need to care about getting the right fake 3D 90s look right very now. So what do we want to do now? We want to basically, we just want to paint, we want to paint whatever we have. So it's like, this is, we get asked to paint and we're expected to paint right away. Like we can't go now and like send out a request, hey, can you paint yourself? Like we need to have something to paint at this point. So I'm thinking web content view is going to have the bitmap already here. So we'll have it as like a ref coder to graphics bitmap. We'll call it the bitmap. Yeah. This will be very naive to begin with, but we'll just make a bitmap when we boot. So bitmap is graphics bitmap create graphics bitmap format RGB32, and I guess it will be actually we can do this in the resize event, because then resizing will kind of work-ish. So that'll be a nice way of doing that, because we'll get a resize event when our widget joins the GUI layout anyway. So like every widget gets at least an initial resize event that tells you how big it is, and that's enough for us to be able to instantiate our bitmap. And wait, what's wrong with that? Resize event. Oh shit, I'm messing up the thing here. Resize event size. Okay, maybe we should call base class to be good boys. Okay. And then whenever we paint, we can just paint whatever we have in the bitmap. So we'll just do like painter, blit at 0, 0, just blit our frickin' bitmap, and blit the entire bitmap, and opacity can be 100%. All right, so, and of course we can assert bitmap here. We should really have a bitmap at this point. But an important part here is that we really want our bitmap to be shareable. So in fact, do we have something like create shared bitmap? Right. We really want to have a shared bitmap. So let's grab this little helper code for that. Or, wait, how does that work? We want to share it with the web content program, because you can create a shareable bitmap, but when you create a shareable buffer, it's not actually mappable by anyone else yet. You have to tell the kernel who's allowed to map this buffer. So we call it shared buffer. Let's do this properly. So we'll make a shared buffer, create with size. And that would be event size times, size area times, wait, is there an easier way of doing this that I'm just forgetting? Maybe there's some dumb way we can do this. Bitmap, to shareable bitmap, to bitmap backed by shared buffer. Yeah, that's what I want. So this is a bit hackish, and we'll probably end up creating 2 bitmaps, but I just want to move forward. So share with, and here we just have to give him the PID of our peer, so the server PID. And that should be it. Okay, so let's see if we can build this. So whenever we resize, what we also want to do is, now that we have a bitmap, we want to send a paint request to the web content process. So what we'll do is we'll do a post client post message, messages, web content server, please paint, and we'll just give it our, I guess, our bitmap rect, and the shared buffer ID of the bitmap, Okay, so let's see how this goes. I am very interested to see what happens. Oh, right, that thing is already running. Oh, and are we not even installing Web Content View? Or did we even end up calling that program? Web View. Oh shit, Web View, right. I'm just gonna make a little alias for this Web View. We'll call it Web View. And we crashed. Well, who didn't see that coming? Come on. So where did we crash? Let's see. So web content boots up and he gets a paint request for this rectangle. And then he tries to map the shared buffer with ID 51, and that does not work out. So we can see here client connection misbehaved. Web content server paint cannot map shared buffer. And then he disconnects the guy. And then we crash spectacularly, but that's okay. We should not fail like that. So, I mean, it's not okay to crash spectacularly, but it's not the end of the world. So it's the first attempt to run it. So let's see, cannot map it. Why are we sending Shabbat 51? I guess it's possible that we've already unmapped that bitmap. So if we can't map the bitmap, then we shouldn't. Actually, we should be lenient in that case, because if you're aggressively resizing a window, you might ask the web content process over and over, hey, can you paint into this bitmap? Can you paint into this bitmap? Can you paint into this bitmap? And if the bitmap is already gone, then we can just skip that paint request, because a new one is sure to follow anyway with a different bitmap ID. So in that case, we probably should be lenient, just because it will even be an optimization, right? We're not going to draw something if you're not even interested in receiving it back. So if we can't map it, then that's not a misbehavior. It's just shared buffer already gone. And we'll just DBG that. Ignoring, yeah, like that. Alright, we still crash. Why crash this time? Has not pledged our path. Well, I'm terribly sorry. You want to load fonts and I didn't pledge our path? What kind of horrible person am I? I guess we'll need to pledge our path and give you res /res where all the fonts and stuff are. I forgot about fonts. Yeah, we're gonna need access, read-only access to res for fonts. We could even do this, because I think, yeah, let's do that. So you have our path, but you can only read res fonts and temporal protocol. Definitely not not very much file system access. All right, why did we crash now? Assertion failed document. Is that the assertion I said was cursed and we were sure to hit it? Yeah, all right. So we don't have a document and we're already trying to paint. Well, I guess then we'll just not paint. That's probably fine. So whatever, if you don't have a document yet, we are just barely born, I guess. Maybe we get a paint request really, really early in the lifetime. Okay, so paint, and then did paint. But we probably need to do we need to schedule a repaint of the window when we get the did paint. So that would be in web content client, when we get did paint, what we really want to do is we want to tell our web content view that by golly, you need to update yourself, my friend. And web content client, let's see, we need to give him a back pointer to the web content view so that he can talk to it, because that's just silly that we didn't have that. Okay, and then we instantiate, oh wait, we need to include web content view. Where we created this guy, right here, we need to just sling him a reference to ourselves. Then we forget to update the constructor implementation. Yes, we did. But that's no big deal. Just do that and we're done. It's very dark. Let's see, shared buffer already gone. Ignoring. I wonder if they're always gone. We do get some did paints here. So let's see if we're trying to paint this web content view. And then here, let's say blitting bitmap with shbuffid m bitmap shbuffid, just so we can see which bitmap we're actually blitting. All right, so he painted into 52 and we're blitting 52. He painted 97, we're blitting 97. It's like a huge amount of allocation going on here, but that's also something that we can improve later, because like allocating and throwing away all these bitmaps over and over and over when you're resizing, it's obviously really aggressive, but it's largely a problem that goes away when you switch to tile-based rendering model, and that's something that we'll definitely do in the future. But right now we just have one big bitmap buffer for simplicity. So why are we getting darkness and nothing else though? That's suspicious. So what do we do to debug this? I guess one thing we can do is to wait, let's see that we're not doing anything stupid here. What is the bitmap rect? Bitmap rect is bitmap rect. And maybe we can also fill with some innocent looking color before we start. So clear rect, my whole rect with color, I don't know, 192, 192, 192. A fan favorite. All right, so that's suspicious that it's just dark. Why is it just dark? I specifically told you to clear the rect. So what is the event rect here? Clipping to event rect. Am I clipping to something dumb? Oh, wait. What am I doing? Am I doing the right thing? I was just thinking, is this thing even instantiated? But I mean, we are getting these debug output. So this code is being called, but it's suspicious that we don't see the gray. Something is not right. So the clip is fine, but the blit I mean, we're blitting over it, so what if we don't blit? And bitmap is presumably all black pixels, because the other side didn't paint what we wanted. Yeah, so the gray is there. Okay, so this code is running. We just have a bitmap full of black pixels that we got from our peer. So let's investigate why that happens. So when we tell him to paint, let's see what he does with that. I know we just wrote the code, but we need to step through this and verify now. So we create a bitmap, and then we say paint into it. And then is it just that we just return early here every time because we never actually get a document, because we never load a URL? That's probably why. We never tell it to load anything. Forgot about that. Okay, so before we go into the event loop, how about we say, wait, how do we do this? This is the web content process. I wanted the web view test program. Here we'll say view, we'll do like view, load, file, home, anon, dub. Welcome, HTML. All right. That's not convertible to a URL because I didn't include URL, I guess. Okay. Ooh, we have a crash at least. Something new. So, P error connect, connection refused. Where are you trying to connect, bro? You are trying to connect to the protocol server. And are we refusing that for you? Yes, we are, because you are the web content user, and he's not allowed to talk to the protocol server, but we fixed that by editing the group file. So we need to allow the web content user to connect to protocol. Now what? We have a crash Mundo because, oh, you're trying, we didn't unveil the error pages. Okay. That's fine, we can do that. I guess I was a little bit harsh with only allowing res fonts. We can also do res HTML because we have some error pages there. Okay, now you're trying to show a message box, is that it? No, wait, what? File, open, oh, it's trying to load some icon. All right, fine, geez, just get all of res. I guess there's more stuff in res that he wants, whatever. Maybe I was being a bit aggressive trying to constrain there. Okay, so we've loaded an error page, but, oh, and see, there it is. But the background, oh, wait, hold on. Is this because of the palette? Maybe it's because of my stupid palette. Where did we set that up? Was that in page host? So let's fix this properly. So what we want to do is we want to send a system theme buffer, like all the colors in the system theme. We just want to send them to the web content process. So in the web content server IPC endpoint, we'll just have like set system theme or update system theme. Buffed. I think that's really all that we need here. And then what will happen is that in web content client connection, we'll get a new call. So this will be virtual void handle update system theme. And when we get this call, massage. What we'll do is, do we have palette here already? No, we don't. Let's get palette up in, or system theme rather. So what we'll do is we'll say graphics, system theme. Oh, no, what's the thing we say? Graphics, set system theme. That's the guy. Shared buffer. All right, so we just need to map the buffer. Shared buffer, create with shabuf ID, message shabuf ID. And the more I think about it, like if it's not mapped, I guess somebody's changing themes really fast. We should actually tolerate that. So I'm walking back my earlier statements about no leniency, because due to the asynchronous nature of this type of communication, if we're told to do something but it's clearly like no longer relevant, then we should just not do it. So we'll just say update system theme, shared buffer already gone, ignoring. Oh, what's that? Okay, return. Otherwise, we'll map it and then make it into the system theme. And then we can just fetch the theme from current system theme. Wait, who's using this? Oops. We'll figure this out somehow. Theme page. So we can get rid of that, but instead graphics. Wait. Page host. What am I thinking about now? We should have some kind of a set palette thing here. So we can create a palette input from a shared buffer. Oh, that's what we want to do. So in the web content client class, wait, no, this is running in the GUI program. Web content server, he gets this call, and we are here. That's right, and then we end up in the page host. Right, so we want to create a palette impl and set that on the page host. That's what we want to do, set palette impl. Something like that. Page host, set palette impl. I don't know, no big deal really. It can even be a const because we don't want to mutate the palette necessarily here. That's fine. But the important part is calling it from here. So set system theme and then palette, and then impl is graphics palette impl create with shared buffer, shared buffer. Does this even make sense? This API is confusing as heck, actually. I don't remember it being this weird. Maybe I should spend some time cleaning this up a little bit, but now that we have a palette impl, we can just say page host set palette impl. Okay. Oh, and then we have to actually broadcast this message to him. So in web content view, when we construct the client, then next thing we'll do is we'll just say post message, messages, web content server, update system theme. graphics, lit graphics, something like that. I think the system theme is shared with every PID, or it's globally shared, I think. Because there's no reason not to share it globally. Like, who cares if any program can find out what the system color theme is? I think that shouldn't matter, since it's a read-only buffer. Did we not broadcast the thing after all? Let's see. So, or wait, hold on. Maybe I should actually try to resize before I say too much. Oh yeah, here we go. So it seems like it has the right colors, and it's a little slow to repaint sometimes. Maybe you get some black occasionally, but then it always pops into place. So that's pretty good. This is something that we could solve by double buffering, for example. Because right now we only have a single bitmap, right? So if we replace the bitmap when you resize, and then a message comes in the meantime that something finished painting, then let's see, did paint. We always update when that message comes in. We could actually be a little bit smarter here and do like, say like mview web, you could say like server did paint, or notify server did paint. Notify server did paint. Oh wait, this is the wrong class. Here. And we want this to only come from web content client. So let's pass a badge. And then in web content view, when we learn that the server did indeed paint, notify server did paint, we just, we can at the very least, we can check if the buffer ID that was updated is the same as the buffer ID we're currently using. Because if there's not a match, then we don't care about this repaint. So, bitmap shbuffed is equal to shbuffed, then we care. So then it's an update, otherwise we don't care. So at least that should get rid of some of that resize, repaint, black noise. Oops. That didn't help as much as I hoped. Anyway, all right. So now, I guess our new problem is the layout is very tight. So it seems to think that it's quite a small viewport. And I guess that's because we never notify it about a new viewport. What do we do here when we resize event? When we resize event, we say layout and sync size. So we always relay out the page when we do resize. This makes sense. We should really notify the web content server when we resize the view. So set viewport size, maybe int size. We could also do set viewport rect, cut straight to the chase. It's probably better. So if the viewport rect changes size, then we react to that. I'm trying to not think too far ahead about scrolling and like the architecture that we want for scrolling to work well. So I'm just ignoring like scroll offsets and stuff right now. So let's just do set viewport rect as an API, and we'll call that from web content view when this guy is resized. We'll have to do a paint, but also a resize. So we can do the resize first. Post message. So this is a little awkward. We're sending like 2 messages in a row, but they're at least they're gonna end up in the same order on the other side. Set viewport rect. And we just give him like a rect that has, you know, like 0, 0 and the event size. And then we need to handle that in the web content client connection object. Wait, there's no mouse down anymore? What did I do? Mouse down is right here. Did I mess him up? Yes, I forgot to name this guy. All right, sorry about that. We'll put him here, so virtual void set viewport rect. Okay, so handle web content server set viewport rect. Message is hard to type apparently. I mess it up almost every other time, I feel like. So our new viewport rect is going to be passed into page. Straight up. And then we'll deal with it there. So set viewport rect. And I think, in fact, what we'll do is we'll actually how is that stored in page view today? Mainframe. What we do when we do layout and sync size is we set the size of the mainframe, and then we call document layout, and then we call set content size. But this is a libgui thing, because in libgui page view inherits from scrollable widget, but I think we'll implement scrolling differently here, so it's okay. So essentially we just want to inform the mainframe about his new size and then call document layout, and then also call mainframe set viewport rect. So that's all the stuff we want to do. So j, wait, where am I now? Page. This isn't where I want it to be. Back up. Maybe this is where I want it to be. Okay, fine. Let's put it on page. Whatever. Set viewport rect. Oh yeah, and this is how the page gets the palette today, so we need to fix this up as well. Because in libweb there are a few awkward places where we cast the page client to a page view, which is totally not right, because the page client can now be something other than the page view. Before we started hacking today, page view was the page client, but now we have also the page host being a page client in the web content process. So we wanted to do something with this, right? So mainframe set size rect size, mainframe document layout, and mainframe set viewport rect. Not completely sure that this belongs in page, but at the moment it's probably okay. The whole frame thing is tricky because of iframes, right? Like, because you don't only have a viewport rect in the main frame of a page, but you also have a viewport rect for each iframe. So And then actually you can even have like divs that are not iframes, but they're still scrollable because they have overflow stuff. So all kinds of stuff to figure out, but not everything right now. So we're calling layout on a null pointer. We shouldn't be doing that. It's very silly. So I guess we can just say if main frame document, then lay it out. Otherwise, it's okay. And look at that. And it relayouts as we resize. Of course, the glitching is a little annoying, but basically does work. Although we're not loading the right content, so that seems like a problem. Presumably because we cannot open that file, it's permission denied. So I think the way we solve that in the browser actually is pretty silly. We give the browser process a write access to the home directory, which is definitely not how we want a browser program to function. So once we have a proper download manager that's a separate service, then we want to get rid of write access to the home directory, because right now the fact that the browser can run JavaScript and create and write files in the home directory, not super good, obviously. So I'm really glad that we're just starting this work now, because this is going to really upgrade the system in terms of sophistication, and it'll be a bit painful as we transition into this new model, and a lot of things will become more difficult to do, but it will also become a lot better, stronger. And we still got permission denied though. Frame loader load. Why can't we load that file? Home and on welcome. What's wrong with that? Oh, I guess I don't even have access to it at all because I am Mr. Web content user. So fine. What if maybe we should just move that stuff somewhere? Maybe it shouldn't be in home and on anyway. Git move base res base home anon we can put it in base res HTML demo or something like that. I don't know. MISC. Yeah, we'll call it MISC. Miscellaneous stuff. And then we'll just update our bookmarks, or not the bookmarks, the start page to be res HTML MISC welcome. Okay, so now it's in res HTML MISC welcome. That's cool. And can we load it? Oh, because I still didn't update web view main. Come on, we're gonna load it, dude. We're gonna get there. Res HTML MISC. Come on. This is 15th time's the charm. And we are here, dude. Check it out. How freaking cool is this? So what do we have now? Actually, let's grab a privileged system monitor. Since I'm such a good boy, Anon, here's a root shell for you. That's Sergey added that today. Very cheerful message. So web content. This guy right here. Check it out. He's running as the web content user. And let's look at his pledge. Wait, you have inet? Why do you have inet? Let's get rid of that. Let's get rid of that right away. Wow, I almost left inet in there. We can probably tighten this harder later. if we like connect to everything that we need connections to up front. But even so, let's see. Web content right here. So, what is your pledge? Stadio RPath Unix accept shared buffer. Very, very tight. Look at that veil. He can read files in res and read in home. Now we don't even need home anymore, so we can actually get rid of that. I just wanted that for the welcome page. So that's great. So web content, and he has he's listening on temporal web content. So like I was saying when we just started, this thing is eventually I'm going to make it listen for connections, and every time you connect to it you'll get a new process spawn. So everybody who creates a web content view gets their own unique web content process. I think that will be really cool because that means that there's no sharing going on. Right now I think we should be able to just kick up a new one, and these two things here, they're actually instances in the same web content process. Wonder if it will survive if we kill it. Yes, it did. Cool. But yeah, this is pretty awesome. Maybe we should see if we can get the mouse event stuff to work as well. That would be nice in our first little prototype, although maybe we should commit some stuff. Let's start with doing some commits. This was just making rendering context take a graphics painter instead. That one is super standalone. Oh, and I moved all of that stuff actually. So let's do the move thing first of all. So here we go. Libweb, or no, base. Move all the HTML test content into res HTML disk. Okay, and then add this guy right here. Libweb, make rendering context use graphics painter instead of GUI painter. All right, and then what was this page change? I guess we'll find out. It was only this change. You know, like I feel like I could drive this out from the outside instead of doing it in page. Maybe it's a mistake to do it in page like that. So where did we call this from anyway? From here, right? Calling directly on the page. So we could just do it here for now. Like page. And we don't have to gunk up the page class. Message rect. Web page. Oh no, I wanted frame. And document. Maybe I should put this in page host even. Why am I putting it here? We already put painting logic in page host. We can also just put this in page host and page host. Set viewport rect message rect. Yeah, page host is the right place to put this. Yes, this is a lot better. And then we don't need to change page CPP or page H at all. So we'll just get rid of those changes. Clickety-clack and clickety-clook. Alright, so what kind of goofy stuff are we getting up to? Just adding the new process. So I think we'll just get that crack-lacking by just adding it. I wonder if I forgot license headers somewhere. If I did. No, I didn't. That's great. So we will commit this. Boom. Web content. Start work on a new out of process web content host service. Out of process web content host service. Yeah, something like that. The web content service provides a sandboxed or a very restricted instance of libweb running as an unprivileged user account. This will be used to implement process separation in a browser, among other things. This initial, this first cut of the service only spawns a single web content process when someone connects to temp portal web content. We will soon switch this over to spawning a new one for each new process for each connection. Or web how to start work on browser process separation, let's say. While bringing this feature up, I've since this feature is still immature, is very immature. We'll be bringing it up inside of a demo, inside of demos web view, as a separate demo program. Eventually, this will become a reusable widget that anyone can embed and easily get out of process web content in their GUI. This is pretty cool. Let's move this guy down here. It's pretty cool. Pretty cool. Love it. All right, so let's do mouse events if we can. So let's see. We already set everything up. We just didn't catch the mouse events, I think. Wait, what did I do there? Wait, I didn't even, did I mess this up now? Does this even still build? Like, did I do a boo-boo now and like commit a bunch of unbuilding stuff? Let's just double check. Because I did move stuff around without recompiling. Don't want to be that guy. All right, so this like nothing shows up until the first resize. That's pretty stupid, so we should fix that. Why is it like that? Why? What is actually the sequence of events when we start up? Let's see. So wait, we don't get anything until we do it first. No, here's something, paint. So it paints this, then we get did paint this. So we have something in show buff 52. But are you, wait, did I just mess that up with my attempted optimization? Let's take a quick look at that. Did I screw this up? Else, no update. Yes, update. I don't know, we're just gonna find out what's going on. Yes, update. Okay, so it's trying to paint, but for some reason, nothing interesting is there. I guess we need to actually, like the web page probably figures out on his own that he needs to repaint after he's done a layout, right? So he's trying to tell somebody, hey, repaint, but nobody's listening. So we probably need to hook this up inside of page.h. Page client, so this is the part where page client comes in, right? So like the page is probably trying to tell us, page did invalidate, for example. So we need to implement this and learn that we need to repaint. So when we get page did invalidate, we can just say in page host, which is our page client. So we'll do this, page host, override. So this is the this is the layout tree telling us, hey dude, something has changed and you need to paint again, and we need to listen to that. So what we'll do is page host. Maybe we are not smart enough to do like it tells us which part of the page needs to be repainted, but we can just be blunt right now and repaint the whole thing. Of course, we'll need to inform our peer. Actually, we need to inform our client, because we can't. One thing here is that we can't paint just because we feel like it, but that's kind of a good thing because it means that we don't paint unnecessarily. We only paint when instructed by our client to paint. So in this case, we can just tell our client. Wait, how do we tell our client something? Page host, we need to communicate something to our peer. So page host currently does not have a pointer back to the client connection. We'll need to fix that. So we can send messages and stuff. So that'll be here. We'll take a client connection. We'll just call it client. And we'll put one of these guys down here and client. Yeah. Because then we can call through on that pointer. Just see that we're passing it everywhere. Yes, we are. Okay. So we can call through on that pointer. Wait, what am I doing wrong now? Page host. Oh. Right. So we will call here. Client. mClient dot post message. Messages. Web content client. So we're actually going to send him something that he knows about. Web content client endpoint did invalidate, let's say. And you know, we can just send the rect along, not like it really matters to us. And then he can decide what he wants to do with it. But it's the rect and content coordinates that needs to be repainted. So did invalidate rect content. Did invalidate content, right? Yeah, that's good. Did invalidate content rect. It's async, and then the web content client class will have to implement a handle function for this. So did invalidate content rect. And when we get that message, what we'll do is we'll just say, I got the message. Maybe also log like the content rec that we got. But essentially, say like, we'll just do an update, honestly. Or wait, is that the thing we want to do? No, we want to tell him to paint. So we don't have to tell the view anything at this point. We're just doing a round trip. So the web content process tells us the content changed. So we get that message and we just turn around and say, all right, well, repaint it then, dude. And this will sort of throttle itself in an interesting way, especially if we get smarter here and start coalescing these messages. But I think we'll not do that right now. It's me figure out a way to coalesce these messages to reduce unnecessary painting. Yeah. But basically what we want to do is just respond. So post message, messages, web content, server, paint. Damn, we don't know how to paint, so we have to tell the view. Okay, fine. Notify server did invalidate content. Right, fine. Content rect. All right. That's okay. It's no big deal. So we will just get the rect here and did invalidate content rect. Content rect, and let's ignore that, and let's not take a value but a const reference, and here we'll just say client post message messages web content server paint, and just pass him the bitmap so that he can paint a new version of the bitmap. Okay. It's a little bit involved, but I think this should do the trick. That's what I thought anyway. But no, it seems like that was not enough, so I wonder why. We're certainly painting, although it says share buffer already gone. So we try to paint. Shabuff ID 52, but it's already gone, dude. Ignoring. So many of these. Suspicious. Let's see, server did invalidate content rect. I just want to see what it says at least. What does it think the content rect is that we are invalidating? Or rather, like, the thing I'm interested in is seeing that the message actually gets there. Server did invalidate content rect, and then there's a big rect. That looks fine. But these are already gone. So let's see what Shabuf we're asking about at this point. So current Shabuf id. So let's see, current Shabuf id is 52. Operation not permitted. So it sounds to me like Shabuf get. I feel like operation not permitted. That means it's not shared with us. So we're asking it to paint into a buffer that we didn't explicitly share with him yet? But how would that even happen? That's so weird. Fine, let's just like hack it here to see if this shouldn't make any difference, but like it looks like the web content process does not have access to the bitmap. And now it did. What the actual heck? I am confused. I guess one thing we can do is do that first, but why would that matter? Okay, let's print out what we're doing here, because now I'm really suspicious. Sharing Shabuf id, bitmap, Shabuf id, with PID, client server PID. Seg violation, of all things. Share with. So we're calling share with on something that's not valid. Oh yeah, of course, because the pointer is not. It's not a shared buffer here. That's fine. So. Wait. Sharing Shabuf id -1. Why is it -1, dude? Oh wait, that's bitmap, not mbitmap. Okay, that's my bad. Okay, so we're sharing 52 with PID24. And then later on, PID24 tries to attach to 52, but he gets eperm. Now, why is that happening? Why is that happening? We do share with. Share with. We don't get any error messages. Do shabuf allow PID. And I mean, it sounds like this thing should be shared now. Share with. Let's do a dummy check here. See that we don't have a kernel bug. I am confused. So invalid argument, that's fine, because it means that we just discarded that buffer. Web content client did paint 52. But here it's fine. 52, we can connect to 52. 52. Web content 52 not allowed. Web content paint into 52. So wait, it works the first time, but then we try to attach to the same shabuf id again, and then it doesn't work? Is that what's happening here? Can you not connect to the same shabuf ID more than once? I guess that's not really something we've investigated before, so maybe that's what's going wrong here. Like, you can only make that initial connection. Frickin' shared buffers. So shabuf get is failing the second time we call it, presumably. And I would assume that we shabuf release. So let's see, shared buffer. When we destroy one of these guys, we'll do a shabuf release, right? And shabuf release finds the shared buffer, checks if it's shared with me, otherwise it's an eperm, and then it's a release. So dref for process. That's nothing obviously wrong with that. Okay, I guess we can do something really hairy. We can do like if process, oh, this is so gross. Process name is web content. Then we will log. Just see what's going on here. Here, okay, so releasing shared buffer 52. We released it. Releasing, released. Yeah. Released. Fine, and then what? Destroy if unused. Is that what's happening next? Current, oh, process current name. Releasing released, but we're not, we destroyed 50 up here, but we never destroyed 51. We still have 51, and we didn't destroy 52. If we do that, then, well, What the heck? So let's see. Buff get. Who is messing this up? Let's log this. Doing a retain, although presumably we're failing before that, so we're failing here. It's shared with. How would that fail? Oh, wait. So the first time you share something with somebody, we create a reference, an empty reference holder for it. But then when you release something, we remove the reference holder. That's the bug. So we can't get rid of these because these essentially make up the permission. This reference object, it represents the permission to attach to the share buffer. And we are just cleaning those up as if they are garbage, but they are actually not. So when we do deref for process, then we don't want to remove it, dude. We want to deallocate the region, I think. What did we do in share with? We want to go back to the state we were in share with. Just appending an empty reference with peer-pid. So count is 0. We just want to clean out the region, deallocate the region, and not throw away the reference. Yeah, that's what we want to do. So boom. Destroy if unused. That's still fine. Total refs. Yeah, that's still fine. Okay. Yeah, awesome. There we go. So we fixed the kernel bug. And it was also tiny. Kernel, don't remove shbuff permission to reattach when releasing. The reference object is not just a counter, it also represents the permission to map a shbuff itself. Without this change, a shbuff could not be remapped after releasing it in a process that someone releasing it. Remapped same process after it released all of its refs on it. Yeah. Great. So let's do a git checkout -p, see if we can remove some gunk. We keep you, don't keep you. Yes, we can keep you, you, and you, and you, you, and you, and you, and also you. Okay, great. Web content. Allow the web content process to drive to trigger paint invalidations, trigger repaints. After layout, we may want to repaint the page. So allow web content process. So we now listen for the page client. What was it called? the page client page did invalidate. Use it to drive a repaint in the client process. Client side repaint. Note that an invalidation request from the web makes a full APC round trip. To the web content client and back, since paints are always driven by the client. Since the client drives painting. Okay. That's fine. So I wanted to do the mouse event stuff, just so at least so we can do like hover over the links and see them show up. Although, wait, hold on. I want to see if the resizing is remotely reasonable. Oh, this is so noisy. But that's okay for now. So let's just, I think we just have to generate some events basically, or generate some messages when you do mouse events on the web content view. So we just need to listen for them first of all. So mouse down, mouse down, mouse up, and mouse and move. All right, the three amigos. And we'll just put these bros right here. Okay. So how do we do this? We just send it to the other side, I guess. Messages, web content server, mouse down, position, and button, and buttons, and modifiers. And then the other side can do whatever he wants with this information. It's really up to him. We are just slinging the event. So let's see if my architecture that I've put in place for events, if it will just work. Wouldn't that be cool? Oh, look at that shit. It just works. Man, that's so cool. Of course there's flicker because we don't do double buffering and stuff like that. But man, how cool is it that it just works? And we can even see, it says clicking on a link to blah, blah, blah. Man, that is so cool that they just work. All right. So, just say, hook this up. I think we're gonna put these like all under the web content banner, even though I'm technically working on the web view demo program. I'll just use web content as the commit message category. So let's say hook up, or pass mouse events through to the web content process. Just send the incoming mouse events across to the other side and let libweb deal with them. Man, okay, so I think we're going to be done here for today, but this is, I would say, a really nice leap in architecture that we're making here. So obviously this is not ready for prime time in the browser yet, but really good progress. and we'll be able to iterate from here and make more improvements. We didn't do any kind of scripting, but that's one thing where we have a very nice advantage coming up, because it's a JavaScript engine. It's going to have bugs, and those bugs will be far less exploitable once we stop sharing the same process between every web page that we have open and stuff like that. Anyway, I got a little bit tired from this, so I need to go have some dinner and stuff. But if you made it this far, then I thank you for watching and for hanging out. And I hope that you saw something interesting here. I think this is pretty interesting work, and I'm looking forward to continuing on it. And I think this is going to be really good. If you haven't already, then please check me out on Patreon and GitHub sponsors and things like that if you would like to support my work. If you would not like to, then that's totally fine too. I'm just happy that we're all here and having fun with programming. So thank you very much for hanging out, and I will see you next time.